Hey everybody, I'm here with a video to help you guys get started on our section 3.7 on rational functions. Before I get into some examples and info for you, I just wanted to give you an overview of that section that we're going to be looking at. Overall, over the course of our 3 days, we are going to be looking at all of these things here that I've listed. We're going to be revisiting domain and intercepts, which we'll do that today. We'll be talking about something called removable discontinuities. We're going to be looking heavily at finding vertical and horizontal asymptotes, as well as what we call oblique asymptotes. And then ultimately our big goal, what I would actually say is like the biggest goal of them all for this section, is we're going to be looking at graphing these things. And I mean graphing them without technology. We are going to be able to break down all the info that we can get from the equation and then be able to sketch what these things look like. Okay? So today our focus is on these four things. That's what we're going to focus on this video to get you started. One, we're going to talk about using approach statements, using arrow notation, kind of like when we were talking about end behavior of polynomials. Transformations to the reciprocal and reciprocal squared functions. So those are some basic rational functions that you have already seen. And we're going to be looking at doing some transformations to that. There's some problems in your assignment that is on that. We are going to be exploring some of the graphs. Like before you know all the details of doing it by hand, you're going to look on the calculator and just kind of see what some of these things look like and getting a little used to it that way. And then, of course, we're going to review domain and finding intercepts just to make sure you're okay on that on the assignment. Okay? So let me move this out of the way and we're going to get started. So that part one that we're looking at, let's see if I can set this here and get it all centered. Rational functions, part A, we're going to talk about approach statements using arrow notation. Again, you've seen a little bit of this with our end behavior to polynomials. But with these rationals, take a look at this graph. This is an example of what some of the rational functions start looking like. There's not just two pieces. If you look, there's actually three pieces. It's kind of crazy. Kind of looks like a cubic in the middle, and then with this like 1 over x on the sides, it's kind of wacky. What you're going to find is that oftentimes with our rationals, you're going to have multiple vertical asymptotes. So I'm going to draw in. They're not actually drawn on this program I used, but those are where the asymptotes actually lie. And they're keeping the graph from crossing those. All right? So as we look at these approach statements, let's see if we can fill these in. As x approaches negative infinity, what we're going to find is as x gets closer to negative infinity, we're trying to find out what is this function doing as we head off here to the left. Well, if you can imagine this graph, it looks like it's getting closer and closer and closer to the x-axis. It's not going to ever touch because there is an asymptote there, but it's getting closer. So the y value that it's getting closer to is 0. Then if we come over here to infinity, as x goes to positive infinity, we actually find it's coming from the other side, but this actually is going to get closer and closer to being a height of 0 as well. So the f of x is going towards 0. Little different than our polynomials where it's going to infinity or negative infinity as it's shooting up or down here. Okay? Now what we can also do, this was just talking about going to either side as you're approaching infinity. What we're going to find is that it's also informational to be able to describe what's happening as x approaches the vertical asymptotes. So if we look at these statements here, we actually have to clarify something a little bit new. If I'm approaching the asymptote at -2, it's over here at -2, right there. That's the vertical asymptote. I am actually doing two different things depending on which side I'm coming from. If I'm coming from the right, I'm going up, but if I'm coming from the left, I'm actually going down. So the way we notate that in terms of a difference from the left or from the right, we use a little superscript, negative or positive. So when I read this, I'm saying as x approaches -2, and this means from the left. So I'm going to actually write that in there, from the left. And so on this graph, that's actually right here. From the left, it's going to be going this way. Okay? So from the left, as you can see, as we get closer and closer to an x value of -2, the values are getting very, very negative, going towards negative infinity. Okay? Now, from the right is going to be notated with a little superscript of a plus. So this one is from the right. And I'm going to actually come towards this asymptote from the right. So it might be more from this side, like that. Okay? So from this side, if I'm coming from the right, I'm actually getting to be higher and higher values of y. So it actually is going towards positive infinity. Okay? So the new part is really just defining what it means to be coming from the left or from the right as we're approaching the asymptotes. So if we look over here, going towards the other asymptote, this is as x approaches 3. From the left is going to be on this side. So that's from the left, we're coming down this way. So it looks like on this side we are also approaching negative infinity. And then from the right is going towards the asymptote from the right. And we are also going towards positive infinity, just like we were on the other one. Okay? So from the left is a superscript of a negative, and from the right is a superscript of a positive. Okay? If you want a little bit more info, on page 279, there's a table that has some of the different symbols and meanings. You guys can look that up as well. Okay? Okay, I am back. I'm going to do part B now. This is transformations to a couple graphs that we have introduced from chapter 1, the reciprocal and reciprocal squared functions. You guys did see them. Reciprocal is actually otherwise known as the rational function, the basic one we learned in integrated 3. F of x equals 1 over x. That is our basic reciprocal function. And the graph looks just like this. It is in quadrants 1 and 3. And it hugs the asymptotes. Our asymptotes, the vertical one is the y-axis, so that's the line x equals 0. And our horizontal is our line y equals 0, which is the x-axis. Okay? The reciprocal squared, we haven't done much work with it, but it looks similar. Reciprocal squared is actually 1 over x squared. And if you look at its graph, because x is always going to be kind of turning positive, it flips the negative piece over here, it flips it up, and it's going to be both above the x-axis. But its vertical and horizontal asymptotes are also x equals 0 and y equals 0. All right? But we still have the same two asymptotes. They're just coming towards the asymptotes from different directions. That's going to be helpful on some of your homework problems. They're going to actually have problems that look kind of like this. Let me show you example 1. Let me move that out of the way. Example 1 here looks like this. It's going to actually give you a transformation, and you're going to be asked to sketch it. What I'm also going to do is write the equation for you as well, though. So if I'm going to take the reciprocal function and shift it left 3 and down 2, that's going to look like f of x equals, I'm going to take the 1 over x. A left movement is going to be a plus on the inside. And then to move it down 2, we're going to minus 2 afterwards. So I'm going to take the intersection of the asymptotes and I'm going to move it left 3, so 1, 2, 3, and down 2, so right about there. And remember, that locator point is really just the intersection of our asymptotes. So I'm going to redraw the asymptotes there, like so. And then I'm going to be able to graph it in the proper quadrants. It's still positive, so I'm going to be doing it in sort of the what was the quadrants 1 and 3, but it's been shifted. So it looks like that. Okay. Second one, if you take the reciprocal squared, it's going to be a similar thing. I just made a new example similar to your homework. If I am going to take a reciprocal squared and shift it right 1 and up 5, I'll call this one g of x. I'm going to take 1 over, now the x squared, I have to move it right 1, so that's before I square it. So it's got to be minus 1 and then squared. Remember, inside changes are what you do when it's left and right. And then to move it up 5, I would just add 5 there. Okay? So again, the asymptote intersection is what is moving on that. So I'm going to go to the right 1, and I'm going to go up 5. There is my intersection. I'm going to probably run out of room here. And that's what it looks like. And then I'm going to squeeze in my graph there. Again, nothing else, I haven't like reflected it or anything, so it's just going to be in this top corner and in this bottom corner. Okay, so that is our first two sections. We're just kind of touching on transformations to those two graphs, as well as talking about that whole approach statement and how we use those notations to talk about what a function is doing as it's approaching an asymptote. In video part 2, we'll go through parts C and D, and so I'll be back in a moment for that.